This lesson shows what is static equilibrium, where no external forces are acting on the unit. The lesson ends with important review on reserve buoyancy and freeboard. The shown unit is in equilibrium because the forces of gravity and buoyancy are equal and opposite. These forces are on the same line of action. The forces acting on a unit can be categorized under external and internal forces. The external forces are due to the environment, and the internal forces are represented by the weight of the unit and its buoyancy force.
Now we see the equilibrium condition without external forces. Now we move weight to port and starboard. Observe the centers of gravity and buoyancy. Enlisting the unit to either port or starboard side, which points remain vertically aligned at all times. The correct answer is G and B. The center of gravity, G, and the center of buoyancy, B, are always on the same vertical line.
For an equilibrium condition to exist, the buoyancy force has to be equal to the weight of the unit. Without any external force acting on the unit, the center of the unit's weight, G, is vertically aligned with the center of buoyancy, B. Normally the point G is above B, but for some vessels, i.e. submarine boats or yachts, point B may be above G. Reserve buoyancy is the volume of the enclosed spaces remaining above the waterline.
Now we add a weight to the unit and see the reserve buoyancy.
Reserve buoyancy may be expressed in volume units or as a percentage of the unit's total volume. Reserve buoyancy provides the extra buoyancy required to handle weight additions, compartments flooding, and storm conditions. Freeboard is the distance measured vertically at the side of the unit at mid-perpendicular from the upper edge of the deck to the waterline at the current draft. The minimum allowable freeboard is the distance from the upper edge of the deck at mid-perpendicular to the assigned load line mark. This distance is established on the basis of the required reserve buoyancy for assuring safe operations. The assigned load line mark and the resulting freeboard limits the draft to which the unit can be loaded legally.
Now we practice reserve buoyancy calculations. A box-shaped barge with the shown dimensions floats in seawater. Given that its displacement is 26,880 kips, what is the volume of its reserve buoyancy?